Alright, so today we're going to talk about scientific notation. Why scientific notation? Because you're in astronomy and we talk about giant things, so we need scientific notation. We also talk about teeny tiny things. So giant things, think numbers of stars. Small things, helium, hydrogen and helium. That's what the universe is made up of, mostly. So why do we have scientific notation? Well, because we have big numbers and we have teeny numbers. And we need a way to write them. Well, yeah, we have them. We just use zeros. Yes. But, in my opinion, nobody ever asked my opinion, but in my opinion, mathematicians are lazy. Now, I have an undergrad in math. I spent a lot of time with mathematicians. Mathematicians are lazy. And they do not want to write out all those zeros. So, they came up with scientific notation. That is why we have it. So let's start with an atom. Right? Atoms are teeny tiny. They used to be the smallest thing that we knew of for a long time. Well, if you take about 100 million atoms and you bunch them all together, you will get the size of your fingernail. That's it. Kind of makes me think of how many atoms are in my body. That must be a crazy big amount that would have to be written in scientific notation. But let's talk about the size of an atom, okay? So the size of an atom, it says it's 1 times 10 to the negative 10 meters. So let's write that down. 1 times 10 to the negative 10 meters. All right. Now, scientific notation, your brain, as soon as I mention that, is probably like, that means exponents. And I totally blocked that out. And you're like, yeah. And then you start to think about it a little bit, and you're like, oh, there's negatives, there's positives, you have to go left or right. Yeah, and if you were taught that, you were probably taught that in middle school or high school. Whenever you did scientific notation, you were taught if it's positive, go one way, if it's negative, go the other way. But then when you went from regular numbers or standard numbers to scientific notation, you had to flip that. And my brain doesn't work that way. I can't just flip it on the spot. So I had to come up with another way to remember. And so I'm just going to get a different color because I'm going to leave this up here the whole time. But my other ways were, okay, if it's negative or if it's positive. If it's negative, it's sad. If it's positive, it's happy. All right. Right? Negative, sad, depressing, negative, positive, cheerful, happy, right? That's a positive thing, right? So, okay, but we're talking numbers. And whenever we talk numbers, we want to talk money. It's the only way people remember anything. So, if you have a negative exponent, your money is sad. You don't have any. If you have a positive bank account, your money is happy. There's a lot to it. Your bank is happy. So this is sad. Sorry. This is a sad bank account. Now, the decimal is hidden here. Again, mathematicians are lazy. We hide things. So there. It should be there, but it's hidden. So when we write it, because it's going to be sad, I'm actually going to start the 1 over here. And my decimal was here. I need to move it. I need to move it 10 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because people like the zeros, we put that in there. You do not need to, but technically. But people like putting it in so they can visualize it. So there's the rest of the zeros. Meters. That's how small an atom is. In meters. Alright. Let's get rid of this. And we'll move on to the next example. Now, the next example the sun. I love talking about the sun. The sun is trying to kill us at basically all times. But we'll get to that much later in the course. The sun is huge. And everyone's like, yeah, the sun's huge. I get it. Big shiny thing in the sky. No, you don't get it. The sun is huge. Think of all the planets, all 8. Think of, you're like, hey, what about Pluto? Yeah, Pluto's a dwarf planet, right? So planets, dwarf planets, asteroids, comets, and anything else you can think about in space, because trust me, it's out there. But the sun, if you take all of our solar system, all the planets, all the dwarf planets, all the asteroids, all the comets, all the meteors, technically meteoroid, but that's okay, we'll get there, and you put them all together, they are less than 1% the mass of the sun. 1%. Yeah, we're tiny little things. Yes. So in numbers, again, because we're doing a scientific notation, in numbers we have 1.985 times 10 to the 30. Okay, so let's write that down. 1.9885 times 10 to the 30. Always remember your units, kilograms. Okay. Exponent. Is it negative or positive? It's not there. Again, mathematician's lazy, not there, so it's positive. So that means it's happy. So we like this bank account. This is a good bank account. So we want this number to go from less than 2 to really, really huge. So here we go. There's the decimal. So I'm going to write this down because I know those numbers are going to be important. Okay. The decimal went from here. And here, I'll do this in a different color so that you can see it. The decimal went from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I'm running out of room. 28, 29, 30. That's where my decimal went. Look, you can't even see me. There are too many numbers. So let's fill in the numbers. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Again, don't make up numbers. You just put in zeros. They're just placeholders. All right. So I used the wrong color, but that's okay. This is how big it is. Boop. 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 There and there. There you go. And oops, silly me. That is how many kilograms are in the sun. You cannot see me here. Let's do this. All right. That is how many. Right? So now you can see why this course needs scientific notation. It absolutely needs it. Okay, it's going to take me a while to wipe off, so just bear with me. Okay, one thing I get asked a lot, especially at the beginning of class, is what exactly is a light year? You know, you hear about it in movies, specifically this one, right? I don't know what this is and why I'm talking about light years with this guy. You're in the wrong class. But what is a light year? Well, a light year is not that hard to figure out. In astronomy, names are not that hard to figure out. You have a light year. How far can light travel in a year? A light year. Well, light goes pretty fast, right? So it could probably go pretty far. And it does. So it's 5, 8, 7, 8, 6, 2, 5, 3, 7, 0, 1, 2, 3 miles. Now I'm going to do this 2 ways, okay? I'm going to do it properly, and then I'm just going to round off. Okay, so properly, we know that it's going to be 5.87862537. I wanted to write the 0, but don't write the 0. Times 10 to the something. Okay, y5.8, because that's the whole point of scientific notation. Number, decimal, numbers. Okay. Now, okay, this is not really saving us much. We probably just should have put the extra zeros. But when we round off, you'll see that it does save us something. So, how many do we have to do here? Whew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Alright, 12. I always leave myself a little bit of a gap because I want to know, is that going to be positive or negative? Well, is this a happy bank account or a sad bank account? Yeah, you shouldn't need to think about that. That's pretty happy. So, plus, I don't need to write the plus. Right. So now if we were to round off, you could just say, oh, okay, 6 times 10 to the 12. I just rounded. Not a big deal. But you can see why this would be a lot simpler than I don't know that. All right. Another thing that we're going to talk about are galaxies. Now, you're probably very familiar with the fact that we live in the Milky Way galaxy. There are lots of stars in the Milky Way galaxy. There are lots of planets in the Milky Way galaxy. But we live in the Milky Way galaxy. So if our name has the Milky Way, are there others? Yes. How many others? A lot. Again, this is why I love astronomy, because it changes constantly. According to the new telescope, the New Horizon telescope, there are only, and I say only because this has actually went down in number, there are only hundreds of billions of galaxies. Only hundreds of billions. Yeah, just a small number. So, because I can't write hundreds of billions, let's just go with 200 billion. Okay, so that number is 2. There you go. 200 billion. Easy peasy, right? Or you could just write 2 times 10. Okay, and again, the decimal has to go here. It's not there. It must get to there. How does it get to there? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Is it happy or is it sad? If you had $200 billion, would you be happy or sad? Or, let's just not go with personal preference, would your bank account be happy or sad? Happy, right? So, happy. Ta-da! Now, you get to practice. Of course, it's math, right? So, I show you, you do. This is how math works. Well, there's something I didn't show you. So, I showed you how to take big numbers and contract them. I showed you how to take negative exponents and expand them, and positive exponents and expand them. I did not show you how to contract a negative. So, well, let's see which one of these top 4 are going to be negative. We have 0.06, 2 with lots of zeros, 48,000-ish, and 0.02. Well, if we're looking for a negative, we're looking for a sad bank account. Options B and C, happy bank accounts, lots of money. So let's look at option A. 0.00000. I think that's right. Okay, so if I want to turn this into scientific notation, first thing I have to do, I have to get that decimal to behind the 6. So let's put it there. Okay, you don't really need to put the decimal there, but that's where it would go. That times 10, always there in scientific notation, so you might as well just write it. Now let's counter out. 1, 2, 3, 4, 5, 6. 6. Now, is it happy 6? Is it sad 6? Again, if that was your bank account, and if you can't see because of all the little bumps, look at the first number over there. If that was your bank account, would your bank account be happy or would your bank account be sad? I'm going to go sad, right? So if it's sad, it's negative. Negative 6. That's it. That's scientific notation. Now you can do the rest.